because we lost the Monday, right? And so that means my plan for processes has just shifted a day, right? And that only means that the quiz will just be put online, the questions will be there. You just type the answer and submit. And please, if we say use 30 minutes, try and be honest about it. If we say submit, work alone, be sure that you work alone. And I know there's a temptation to maybe Google the answer, please don't be tempted. I'm trusting that people will be honest, even for online activities. All right, so this week, what we'll do is we'll finish our processes. That means looking at what are the scheduling issues and also looking at communication between processes. As usual, we'll start with the discussion and then we'll take a break. And when we come back, we'll look at some samples of code. The code, I would have had the interprocess assignment in this code, but this code, all you have is fork and exec. I think that's what the assignment is mostly about, just using fork and exec. That means the next one will have some interprocess communication, including possibility of using Java and sockets, right? Since most people use Java. We'll be shifting to more Java lately. But if people are thinking of doing projects, so you can start thinking of, hopefully as you are seeing these different aspects of the OS, you can start thinking of what would be cool to do. About halfway through the semester, I'll propose some topics for final project so people can pick. But I'm hoping that people can see different things that can be done. Right. So, interprocess, before interprocess communication, we're going to finish up with the scheduling. This is a review of what we had last time. So, last time we said that this was how processes work. Starting from new, being admitted, they go to ready. There are I/O events. So people should realize that a lot of scheduling concerns I/O events. I/O event is someone requesting to use some resource, such as a file, maybe a device. And that means that whenever you're running, if you make such a request, you are going to be put into a ready queue. And when that item becomes available, you are going to be moved back to ready so you can be picked to run. Right. What I also mentioned was the diagram had to be extended a bit, right? Because in the book, even though they just present one diagram, there are actually two types of ready, in that you can be ready as you are ready in memory, but there are some processes which will be shifted up to hard disk when there isn't enough memory, right? So even though from new, so new means that there is, and I've written it there, a long-term scheduler who is going to look through and decide who gets to run. Because there are many requests that are coming in. And that's a lot like a company that's running and you're getting job requests. Which one do you prepare for? Or which one do you read about? So you are ready. Right? So the long-term scheduler will do that. Even though you are clicking different things, it would have to pick who gets to what. Get prepared to be put into ready state. Once you're in ready state, most likely you are in memory. So that means you have some space in memory, everything is prepared for you, and you can be picked to run on the CPU. But what if there are too many processes that are in memory? What starts to happen is swapping occurs. That means ready programs are moved onto the hard disk. That means they are copied more or less, it's almost like a photocopy of exactly what is put into hard disk, so that it frees up space in memory. So over time, if you have too many processes, this is what happens. Hibernation is also very similar to this. For those who have seen it in computing, when they say hibernate, that means that often every single process in memory is going to be loaded off to hard disk so that the whole machine can power off. Because remember, when you're on a hard disk, you're not going to lose your information if it goes off. But if you're in memory and everything goes off, you will lose your memory. So for hibernation, a lot of swapping, that means you're going to be moving almost the entire memory into the hard disk so that you can shut down the machine. But when you're starting, it's going to move everything back into memory so things can pick up where they were. Right. Sleep mode is a little different. In that sleep mode will keep things in memory, but will shut down other devices. So maybe your screen will go off, your hard disk may be no power, but memory has to be kept on, so that those that are in memory do not lose their information. So this was where we got to last time. Any questions about long, medium, and short-term schedulers?
About the medium-term scheduler. So when do you get to swap between Unix memory and Unix?
All right, so for example, let's say you are working on a task. Maybe you are doing a lot of Excel work, and you have some PowerPoint slides that are also open. But most of the work you are doing, you are just switching, and you can switch by doing Alt-Tab maybe in Windows, switching between tasks, and realize these are the main things that you are doing. But you have some PowerPoints open. You have not used them in a while. It will move them if there's not enough memory. It's better to move those onto the hard disk to make space for the other things that you are doing. Right? So it's not something that's going to happen immediately. It is when memory becomes more or less limited as you are running more and more things. Okay, so he's asking about a partition in Linux that they call swap. Right. So in most Linux systems, when you are installing, it will create a swap partition, usually some fraction of your main memory. So what happens is there's going to be some part of hard disk to make it more efficient. So it doesn't want to be fighting with the main OS for space. So what it will do is on your hard disk, it will pick up a small partition about the size of your memory and say, this is swap space. Meaning anytime the OS needs to move something from memory onto disk, it doesn't have to start worrying about, I need to find space on that disk that other people are storing their files on. It will just say, this is a space, a small partition that I can put my memory processes or memory data on. Right. So it's a partition. It's not a process state. It's a partition on the hard disk. Right. The Windows people will see something like their hidden files. If you enable hidden files, try to remember there's a page file. There's also something like hibernate.sys. There are some hidden files on Windows. So even in Windows, when you are doing hibernation, there is a hidden file on your machine that is used to store memory, and it will actually allocate the entire space that it would use. Meaning, anytime you enable hibernation, Windows is also going to take up some space, so that when you ask it to hibernate, it can actually move the data there. It's not that when you ask it to hibernate, then it's searching for space. So there's a big file, empty file, sitting on your Windows drive if you have hibernation enabled. Right? So the similar principles in Linux are also in Windows. Said that the Linux people call a swap partition, meaning there's some space that they have made for the swapping. Right? Whilst the Windows people may call it a different thing. Right? But there's still some reservation of space. So I hope that this is pretty simple. Okay, cool. All right. So let's move to.
You're saying that two types of ready. When it's moved by the million trends, but when it's being moved back, don't you have to?
It's not going to go through new again. So remember, the ready means that there's a queue of processes. So the short-term scheduler is picking from that list. So if someone is moved from that list, it just means that he's not going to pick to run. He's not going to pick to run on the CPU. Right?
Well, the long-term scheduler have to reload it.
No, the long-term scheduler doesn't come in again. So he's just concerned with those who are new and getting them ready. So it's like admissions. But once they are here, then there's this that has to decide who is actually on campus so that they can be scheduled and who is going to be sent off campus because maybe there isn't enough space. And that's also possible. I mean, we've talked about maybe having shorter semesters where maybe the CS people come for a while. Okay, those are all extreme designs, but it's possible to have CS come for 3 days, BA come for, and just pack things. But there's so many interactions now, I think such systems are not possible. Right. So the medium-term scheduler does not need to prepare processes. All it needs to do is just copy them from hard disk to memory and from memory back. Right. Now, what I've not mentioned here are the different types of schedules that are used. That will be done a little bit later in chapter 6. But there are many different schedules, and you've seen them already if you do any sort of queuing. There can be first come, first served, where if you get there, depending, maybe in the canteen queue, whoever gets there first gets served. There could be priority queues. That means that certain people can jump the queue, and you can see maybe when the freshmen came, they had to maybe attend certain events. So they had a different line, and when they get there, they get served at a different rate than everybody else. So there are different strategies, same ones that you have in daily life, right? You can implement them in code. So it's just a queue, meaning there's just an array, and you are just going to pick the next person who will run. So if it's a priority queue, that means that you just look at their priorities, scan through all their priorities, and pick the highest priority. If it's shortest job first, that means I just scan through, find the shortest job in the entire queue, and move it. So the queues don't necessarily have to be first come, first served. They can be scanned with some sort of policy. Right. All right. So now let's move on to. All right. So interprocess communication concerns how do processes or why do they even communicate. This is also, I hope, an easy topic to pick up. Right. And so today we'll just do some paper activity, not for grading, but just so that everyone, well, maybe I should pick it up, just to make sure everyone has done it. Because it's not difficult, but some people seem not to.
Are you recording?
Yes, I am. I didn't put up the Friday one, but I put up the Wednesday one. Okay, so I have to put them up. Sorry, sometimes when I get to the office, I start and then if I forget, but I'll put them up. All right. Okay, so that means Friday, because I think it's maybe because it's a late class. It's like the moment we leave, we are going home. All right. So back to IPC. Right. So in any system, such as campus, business, there has to be some communication. Right. Because there are many actors and many tasks. So I ask you, why do we need to communicate? So that's my first question. Why do we need to communicate? Some people have read the chapter, you can spit it right out. But if not, there's some reason why human beings or things need to communicate. Why do we need to communicate? Even without OS involved, why do we need to communicate? To anybody, why do we need to communicate? All right. So sometimes for some sort of convenience, right, it is easier if you can communicate with someone. Right. So maybe you get to the hospital and you need to get your card, but you left it at home. It's good if you can just what? Call somebody. Or maybe you're at the bank, you forgot not forgot. Maybe you're at the bank and someone needs to deposit some money before you go and join the queue. It would be nice if you know the money has been deposited before you even go in queue and go all the way to the end and find out the money was never there to start with. Right? So as she's saying, you need to communicate because it's going to make your life a little bit easier. Right? So aside that, so in workplace, why would we communicate? So now think of how can we make, like by communication, can things be more efficient? Right? So things can get much more better, even if you are working on a project, right? In assessment, we have all these group projects. Things have to be done. Is it just one person going to do it? Or you communicate with your friend in some way and say, you take chapter 1, I'll take chapter 2. Right? And that you can what? Have more performance, that's more throughput. Right? So you can get a lot more done too just by communicating. Right? And sometimes you can, this is from a design point, you can break your task into little pieces. Right? And I know that in design, we talk about that a lot. That is, I don't know, say top-down design or bottom-up design, but there's a term that you guys use, decomposition. Is that the word you use? Fractionation. That's the word. Okay, I've heard so many words, but I've not heard that one. There are more. There's a common term on campus that people use for problem solving. Divide and conquer, right? So you realize that for most of the things that you are doing, it's easier if you can break the task into little pieces, right? But if the task is going to be broken into little pieces, then it means that there has to be some communication between the top parts and the ones that will need information from one step to the other. So maybe you are designing a house. If you are designing a house, maybe you'd like to know what's the size of land, but that land size is going to be passed off to the architect, who would also need to find out how many rooms, how many floors from another. So if they are going to break down a task into different parts, there has to be communication to facilitate that process. Right? And this is listed, well, as far as OS is concerned, in just 4 groups. The first one, just information sharing. It's good to share information. Right? If you share, just because you have different tasks that need to be performed, and they will have some dependencies. The second one, you can make things a little bit faster. For computers, if you have multiple cores, it will help. But usually, if you don't have multiple cores, it may just be more switching. But speed up. So right now, why most computers are doing dual core, quad core is they can split up the work and different parts will be running at different speeds on different computers. So if maybe you are browsing, you are playing a YouTube video, there is going to be something that is taking the video and displaying it on screen. It could be software, it could be a hardware device. Even the things with encryption, these days some of the machines have some hardware that does encryption, meaning that as the work comes, it's going to split and say, oh, on this web page, there's this person who's doing the rendering, that's the video part. There's someone who's also doing the display of the text. There's someone who's also doing the sizes. There's someone handling the tasks. Which is why for Chrome, when you opened it in the task manager, you could see there were so many pieces to Chrome. Of course, it doesn't mean that those people who are like Firefox, you see one process. It doesn't mean that there is no breakdown of tasks. Because it's possible to have multiple threads in one process. So thread just means that within one process, there are multiple program counters that are working at different rates at different parts of the program. Right? And so if you can have that, then you can have more scale, more speed up. Right? Or even databases. I'm teaching that course coming in an hour and a half. That means if someone is doing a query, someone is using one table, another using a different table, they can go to different processes, maybe one on first core, one on another core, and they can work in parallel, right? If they can be separated a bit. So if you can have communication, you can also speed up your task. Modularity and convenience have to do with, as I said, design. That if you can split up your jobs, you can have that modular design that you like. That means if you are in software, you can break it down and do modular testing. You guys are doing software engineering, right? Okay, so in software engineering, being able to break things down into pieces, I'm told would help your, well, I'm sure it will, definitely help your design. It will help your coding part because it won't just code everything in one big block. You can break it into pieces, test each one separately, make sure they work. So that modularity helps. Convenience as ease of use. If you can split the jobs up, for human beings, it will also make our work easier. So you can see a lot of interfaces in Windows, Linux, even the phones, starting to give you almost, you open a page, and this page is for maybe creating or setting up your battery, another page for maybe the display, another page for managing tasks, another page for calls. So if you can split things up. You can also have some convenience for the user, right? Which everyone does. Now, there are two main ways. So there are many ways to characterize communication, right? So this is just trying to get you to think of the resources that the computer has and how it can use those to solve the communication problem. The first is, remember the kernel is what? The part of the OS that's going to be handling all the system calls and all the requests that are coming in. So one way to do communication is, let us tell the kernel who we want to send a message to. So I'll tell it, okay, I want to send a message from process 1 to process 2. And the kernel, remember, if you make a system call, the kernel will come in, right? It will swap you out, will come in. We'll look at, okay, this guy has a message ready. I'll copy it, and I'll go and put it into the other guy's space. So you can rely on the kernel to pass messages between two processes. That means whenever the kernel comes into play, he can look at all the messages that people have requested to be sent, and he's going to move it from one process space to another process space. He could even decide that when you make a message call, he'll keep the message for you, remove it from your space entirely. And then when the other process comes, he would put it in that process's memory space. The same way you do file I/O. If you open a file, that means the kernel will go and prepare the file so that when you read from that object, it gives you the data. You can do the same for messages. Right. The other one is the kernel knows that everyone is using memory, but it can facilitate communication by setting up some spaces where two people can read without causing an error. Say, well, you have 1 to 100, another person has 100 to 200. Let's make from 200 to 300 the shared space that two people can write to. Meaning that when A is running, he can write to that shared space without causing any error. And when B is running, they can also write to that shared space. So using those, you can have communication between them. Right. Now, the one where you have shared memory, when we get to threads, you realize that threading enables sharing almost automatically, because when two threads are running, they are within the same process space. And that means they don't have to go through any of these extra mechanisms, either to rely on the kernel to send messages, or to rely on the kernel to have some place where you can read memory. Right. Now, this part is important because remember we said the kernel has to protect against people accessing memory illegally. But for this shared memory to happen, it means that it has to make an exception, that for some small part of memory, 2 or 3 processes can read, and the kernel will enable you to read. Well, and also write. Writing means that you want to send a message. Reading, you want to get some information. So these are the two main ways that people can implement message passing. So is everyone cool? Or no? Question? For the threads. Okay, so what I said was, first, either you can rely on the kernel, right? That if you want to send a message from one person to another, almost like in an exam room, if you want to send a message from one to another, we'll tell you, ask the invigilator or whoever is supervising to come and pick up the item sent to someone else, right? So that is like the first one. That means you don't directly touch each other in any way. Instead, you make a system call, maybe raise your hand, and then kernel is going to come over, take the message, and whenever he finds the person who is going to go and deliver. But in the second one, we are going to talk about shared memory. That means that we're going to give you, the two processes, some space where both of them can access legally without causing any issue. So that would be almost like saying, okay, we're going to have exams, but now we're going to have a shared sheet, right? Okay, shared sheet is not a good one. What do people usually share? Like shared erasers. So if you want to share something, we'll just put it in the middle, and both people can take it, and the examiner will not what? Will not cry foul. Meaning that if we have something that's shared, maybe there's some notes you need to reference. They are open book exams and so on. There's something you both want to share. If that's the case, we'll put it in a common area, and whenever you need it, you can come and pick. But having the common area is going to what? Enable information sharing. Right? So in information sharing. If I said in an exam that I'm going to have a sheet here and anybody can come and write or read from it, some people may be very happy. Right? Because that means, okay, now you could maybe communicate, because you could get up, write something down, and someone else will come and pick it up. Right? So if that is allowed, of course, for some things it may be a good reason to share. Maybe I have something like a group exam where I say, oh, okay, you are all working in a group. Here is a sheet. Design something for me. It's possible, right? In that case, having a shared area facilitates this communication, right? I hope you are seeing the okay. So that means if we have the shared area, or even in an exam, usually there's a board that everyone sees, and then we write something on it, and everyone can see it. That means there's this shared area that everyone can access or can see, and using that, you are facilitating communication, right? So the first one involves message passing. Meaning that the message is going to be what? Encapsulated in some form. Someone picks it up and will deliver. But in the second form, the shared memory, meaning there's some shared space that both or all the people who want to communicate can access. And that way, you can pass information from one person to the other. I'm sure you've seen this in many movies, those spy movies, where someone comes and puts something down and someone picks it up. It's the same concept with shared memory. There's something that both people can share. With the shared, you need the kernel, because remember that the kernel usually will prevent people from accessing the same memory, because it prevents one person, like in an exam, from communicating with another person. It makes sure that when you come and sit down, you write, and when you're getting, you take everything away. But if I can say, okay, now let's have some shared space. Maybe there's a desk. I say, okay, we can put things here. Whoever comes in can access it. That will then enable communication. Right? Because usually you are not allowed to communicate outside your space or into someone else's space. But if the kernel can say, oh, part of the space, so remember when you make a read from memory, what the kernel does, remember it keeps a list of all the resources you have. So it'll say, okay, you are supposed to access from 0 to 100. If it puts, in addition to that, the shared memory space in another person's space for you, that means that you can now access it without causing an error. Because usually when you try and access something that's not directly in your space, it will kill you off by saying you are misbehaving. But if you want to do shared memory message passing, that means that some system call will allow you to specify some block of memory and say, write to it. And another person can also write to it. And that will facilitate communication. So that means that there will have to be some, it's good if you have some mechanisms in place, right? So if we are doing shared memory, that means you can leave it up to the processes. Remember, it's just like threads. When threads are running, what they can do is they can set up locks and so on. That, okay, maybe there's a variable. If I write to the variable, then it belongs to me, right? So you can have something like that where you say, okay, maybe there's an owner ID. If I put my name there, then that means that I am currently the person who can use it. And if you are going to use it, there has to be some best practices. That before you access that space, check to see if someone else has written to it before you also write to it. So there can be some mechanisms that you can put in place. We'll see this when we do threading, but we'll see some sample code in this chapter as well. So if you are going to do shared memory, that means that there's going to have to be some code that makes the work a little bit easier. So that means something I'll check. Has someone put data there? Can I pick it up? Right? Or maybe there's some counter that people are incrementing, like producer-consumer. One person is adding, one person is removing. So there's some variable that when I want you to pick up something, I'll go and implement the variable, and then you can look at it and say, oh, the variable has changed. Or if a message comes from me, I go and put something in the variable, you read it and say, okay, there's a message for me to pick up. Right. So these are the two ways. Are people cool? All right. So moving on to more ways to communicate. So the first one, we are just looking at different dimensions of communication. This is the first one. How is it implemented? In the second one, how does the message get sent? Is it with a name? So maybe you're writing a letter. So in the past, I think maybe it'll still work. When you're writing a letter, because there were so few people, Sometimes you can just write the name and location, and somehow the postman will deliver it. Just figure out this person lives here, right? So in that case, you are talking more about direct communication. That just by specifying the name, the message will get sent. Right? So it will be interesting. Maybe in future it will happen where everybody, maybe if everyone has GPS enabled, I could just specify your name, right? Maybe your unique name and maybe birthday, and knowing that that thing has described you, I can attach a message and the message will be sent. So if you have that, we call it direct communication, meaning I'm naming the person that I want to send to. Right? Now there's an indirect communication where, similar to mailboxes, nobody really knows who owns it. You just assume that maybe that is the owner of the thing. So for mailboxes, someone could say, send a message to post office box 119 or something. And that means that when the message gets there, whoever opens the mailbox, is going to take the message, right? Or if you are also sending a message to someone else, that means that when you are replying, you just put it in that mailbox, and the person will pick it up. The problem will be when many people are sharing the same mailbox. But if you can arrange it so that different people, when they need mailboxes, can specify, I want mailbox number 1, mailbox number 2, and so on, then you can just specify the mailboxes without specifying the name of the person in particular, right? So this is something that we have in real life, mailboxes. Either you specify a name. I don't know how mail is delivered on campus. Do they bring it to you, or is there a mailbox? To the reception. So that's almost like a naming approach, a direct approach, where there's some location, they write your name and they say Ashesi, and somehow, either at the reception, I don't know, that's okay. At the reception, you come and you show up and you pick it up. But there could also be, maybe one day we'll have it on campus, mailboxes, where students who want to have, maybe operate some business or something, can say, I've paid for the mailbox for a year. Mailbox number 1, I've paid for mailbox number 2. Any message that comes, you get a key. You go, you open it, and you pick up your message. If you want to send a message to, you can go and put it in that person's mailbox. Our school used to have that. I don't know why. It would be really cool. Right? So that even if you wanted to send a message to someone, you just go to, and everyone has a mailbox. If you know the person's mailbox number, you go and put the letter in there. And then the person, when they come back, can pick up their message. But then if the ownership of the mailbox changes, then that means that the message is going to a different person. Right? So naming means that you are going to, when sending a message, specify exactly who the recipient is. Whilst for the indirect communication, usually you just specify the mailbox number. Right? Currently, a good example of indirect communication that you have is like web browsing. You all assume that when you type an address, it goes to port 80. That's the default web browsing port. But port 80 could be assigned to anything else. It could be a database server. It could be a mail server. It's just that by convention, people would say, 80, maybe Apache has it. But even if you have one machine, you can realize, for those who did databases, that when you have maybe 2 or 3 versions of the same database, you start one, you try and start another, and it says that the port is already in use. Meaning that they are competing for these mailboxes. So the OS is going to own all the mailboxes. But then, it would say, when a message comes, I'm going to deliver it to a specific program. So when you start a web server, for example, it would say, I want port 80. Meaning any message that comes from outside port 80 is passed to the web server. Or if you start a DBMS server, maybe you start, I want port 3306. That's, I think, MySQL. Meaning anybody who is connecting to 3306 on the machine, the message will be passed on to the database server. So this is currently very much in use in most operating systems. Right? So are people cool with these approaches, the two? Either you specify the name when sending a message. So this is just almost like trying to put your mind into an organized way. Right? I know you know all of these already, but you didn't classify it this way. You know that you can send a message to someone just with a mailbox. But I didn't think that it was something that was happening in an operating system. So you're just saying that the same way you send a message, you can send a message just to a mailbox without specifying a name. That is possible. The OS has either sockets or ports, these numbers, and processes can request to use certain ports. Meaning when a message comes to that port, the OS will pass it to the process that owns it. Or the other one is, but this one is less common, except maybe you're using a library. To say any process that is running, you can specify the name, but processes have process IDs, right? So you can say, okay, send this message, especially kill signals. I don't know if people have typed, you can do kill and say the process ID, meaning that a signal will be sent. That means it's been named. Every process has an ID. So you can say kill or suspend or That signal is sent to that process, and that process will perform the necessary action. Right? So there are some forms of communication where the item is named. That process ID number 1, do this. Process ID number 2. Right? That is more what? Direct. Whilst the ones where it follows the ports and the sockets, you are not really identifying a process. What you are doing is you are identifying a mailbox number that it will get to, and whoever owns that mailbox can what? Respond to the request. This is something you already know. I'm just putting it in a nice table for you. Direct and indirect communication. Just with big words at the top. Direct. That means named. Indirect means that what? Something in the middle. Some mailbox. So these are the two ways as far as naming is concerned. So any questions? Okay, so to another one. Maybe spy movies are but no, those are kind of getting. Okay, so let's use in the computer. All right. So in the computer, there are many of them. So the one that I was giving was with the ports, right? So every program that is running that needs to communicate with the network is going to get some. Okay, so let's start with your machine. If your machine comes online, right, joins the school network, it's going to get an IP address, right? That means that if something is sent to the IP address, maybe I ping your machine, it is in a way indirect, right? Because your machine may have a name on its own, but now it is given this number that anybody who sent an information to that number can communicate with you. But it doesn't mean that just because you have that number, it's always coming to you. Another time, she would come to the office, connect to the network, and she would get the IP address. So if the IP addresses are things that are changed, being sort of randomized around, that means that there is this number approach where we would say, okay, anytime you want to communicate with someone, you can specify the IP address. I'll show you how to do that in Linux when we get to that. Right? Or even when you're on the same machine, you can specify, okay, I want you to send a message to this IP address. In that way, it's almost like a mailbox. In that whoever kindly owns the mailbox gets to receive the message. So if you want to run a web server, maybe for some school shopping thing, that means you will have to find a better way than to say, here is my mailbox. Because if the mailboxes are changing, then what? Sometimes we come to you, sometimes we go to someone else. Right? So in the real world, a lot of services run that way. Right? Now, one way that you can get around this is some people may actually give, so maybe if you're on campus and you wanted to have a machine that has the same address all the time, you could speak to the IT department. And what they will do is they'll make sure that maybe every time your machine comes online, they'll check the MAC address. That's a unique identifier for your machine. Every machine has a different MAC address, unless you've hacked it. Right? So you check the MAC address and assign you the same IP, so that next time when you come online, you get the same address, and what? All the communications that are meant for you will keep coming in. Right? So there are some things on campus that have the same address no matter what they do. Maybe your mail server, I think the routers have, please don't go and do things to the IT machine routers. Right? There are routers, wireless devices that have almost the same address. Meaning anytime you connect to them, someone would say, I'm a gateway. Everyone is using that same gateway. It's not something that will change. But there are some that are going to work like mailboxes, which is like the IP addresses. Anytime someone comes, you get one. And then you can communicate with the server. The server sends the web data to you, you also send it back. Right? So in networking, you can find it. In normal software like databases, you can find it as well. Right? That is, on my machine, I could have 2 or 3 different versions of maybe MySQL. But they can't all work on the same port. Because what will happen is when MySQL starts, or some server starts, it will ask the OS, I want to use a certain port. Maybe port 80. 80 is for web server. 3306 is for MySQL. Different databases have different ports that they will use. Meaning that when your server starts, you will ask to use a certain port. And that means that any communication that comes will be sent to the software that has to use it. Right? So in software, this is also happening with sockets and ports. So are you cool? All right. So some of this, that's why some of these classes, it helps if you've taken a few, so that when I give the examples, it makes sense. In programming, when this example won't work at all, they will just say, what's MySQL, what has it done? But for OS, it seems to work because everyone has done some version of database before.
What's the main purpose of using the ports indirect communication?
Okay, so you realize that they serve different purposes. One of them would ensure that information is going to a specific person, such as signaling a process to suspend or something. That means you can target a specific process, and that's useful. Maybe you are shutting down, and you want to tell process that is doing your database to shut down. It's good if some of them can also accept messages over the port, but if something is running, but you still want it to shut down, it doesn't have any ports. It's good if you can send a message and say, "Oh, this message, there's." This process, there's a message coming for you that you have to shut down very soon. And you can see Windows, I think Windows does this these days. When you try and shut down, it would say some people are shutting down. And what happens is, for all the people who are waiting to shut down, it has to send it a message. Okay, so she just threw me off. Okay, so we're comparing the two, whether we should go with direct or indirect. And I'm saying that both of them, within an OS, they do occur. Right? So in Windows, when you are shutting down, for example, then the more recent versions of Windows, what will happen is, they don't just shut down immediately. What they will do is, they will list and say, some programs are still running. Right? But if you watch the list, as the time goes on, the list starts to reduce, because they start to shut down one by one by one by one. Now, it's possible for the operating system to send, usually it's signal. It can signal to different processes to say, oh, please die, so please kill, or please shut down, or please suspend. So it can send it a message, meaning if the program has some things to do, meaning it needs to save some file or store something before it dies, it can do so, right? And so that one is very nice, and that means that you can directly send information to different programs. They don't have any mailboxes. That means they are not on any sockets. But the OS can still communicate with them just by specifying their name, that you, this process, do this for me. Right? Now, another thing that can happen is sometimes, especially with services that are happening between two or more processes, maybe web services, database services, and so on, there will be a need to communicate with the service. But you don't always want to say, let's say MySQL. You don't want to always to say, MySQL that is running in my XAMPP folder, do this. You just want to say, oh, I am running MySQL. It doesn't matter where it's running from, but it's listing on port 3306. It means one day I could change my mind and say, I don't want to run in a XAMPP folder anymore. I installed it and now it's in program files, XAMPP. But I still want that program to receive those messages. Right? So there are a lot of systems where we think we are communicating with one machine or one program or one service. But in the back end, what they will do is, at different points in time, different processes or different programs will be waking up to listen. And based on the design, the person can pick different. So let's say I have a company and I'm trying to scale up. Maybe I'm using MySQL, that's fine. But if I get an enterprise version of MySQL, I'll just do what? Shut down the old one, start the new one, assign it to port 3306, and it will take over. But the front end user doesn't need to know the details. So having these mailboxes, it hides the details of exactly who is what, handling the request in the background. You don't need to know. So if maybe we switch from Apache to a Windows web server, you may not know, because what? It will just be we copy the files to a new machine or even to a different folder, start a new web server, still listen on port 80, and you won't be able to tell the difference. Right? We could start one up and shut down within a second, and you still wouldn't be able to tell. Right? So there are some things where you don't need to specify the exact name. So a front-end user doesn't need to know Apache is doing your web server or Windows is doing it. He just needs to know here's a port 80. Anytime you make a request to port 80, something is going to reply to it. Right? So in that case, where is it? How could it go? Okay, back online. Okay, so it means that anytime a request comes in, the program doesn't need to know. All it needs to know is I send something to this box number or socket, and I'll get a response. Right? So that is useful. I have to move it to my... Okay, so any other question on direct versus indirect communication? So a lot of the web servers currently are using ports. It's highly unlikely that you directly say, I want this process to do it. From the outside, they just get the port number. So they'll just say connect to port 80. That's for unsecure. Connect to 433. Okay. Those two numbers always mess me up. It's using a mailboxing system.
And in their example, they allow you to control the mouse and the keyboard of another computer. How are they doing that if mouse and users don't want to use ports? Or they also have a way of doing it?
So that just means someone has to write some software that would receive message on a port and send it to the mouse driver to do the action. I think it's a good project. I'll add it to the project list. So remember, all you have to do is what you receive on a certain port. It can even be a web like port 80. So trying to remember, is it VNC? When we were in Laboni, there used to be this software where you'd install in the browser and then students can watch you when you are working. So when the projectors weren't working, I think, VNC should be able to do that. The person can just go to the browser and then can be watching as you work. Right? So all it means is that there will be one program who would be handling some system-wide operation, maybe taking snapshots of what I'm doing. But on your program as well, on your computer, there's another one who is going to receive and then translate. So if it's about moving the mouse, that just means that one machine takes it, sends it over the network to another machine, that's another port. And on that port, there's another program there who would take the request coming in and then do the action. If what's happening, maybe controlling mouse, is something that is going to be a privilege call, then you need some software or some privileges to control it. For viewing, normally it's not privileged. It's just going to be, it appears like a video. And so it takes the snapshot, sends it over, nothing serious is happening on your machine. But for something like controlling the mouse, usually it's going to be a privileged action, right? That means, yes, someone has to code, make some application, or write some library that would bridge that gap. Right. So it's just like you can. Okay. We'll add this to the lab. So you can. There are a lot of these labs that people have done before. For example, I think last year we had where we would say let someone type a command on one machine and send it to another machine. So not SSH, but it can be over web. That just means that on one machine there is a process that's listening on some port. And when it sees certain text coming, it will perform certain actions. Right. And it has many benefits. For example, I don't think we do it on campus, but on our campus we used to have computers, but if you shut them down, the IT department knew you were shutting them down. Because anytime you try to shut down a machine, or you disconnected, here we don't, but it would be nice to have, you disconnected the Ethernet cable, or you did something. The moment some things are not coming through, the IT department will be on you in like, it's like real time. You know, you're unplugged and the guy is behind you. Hey, what did you do? It was exciting, right? But at the same time, there were some benefits. Benefits such as they could tell when labs were getting full, right? So maybe if you knew that lab 1 is completely used, then you have to think, okay, do we have to open up another lab? Do we have to get laptops in? So there were some benefits to that. But that just means that anytime something happens on one machine, it communicates over the network to some port on another machine that tells it, okay, someone has just disconnected my mouse. Someone just took off my keyboard, right? And that way, they can communicate. So it doesn't mean that just because some aspects of the OS are direct and some aspects are indirect, they can't communicate. You just need to write some program that can receive the message on a port and then make the direct call to this one so that it performs the task. Just the same way like you have a web server. When someone opens a web page, the web page, like if it's Apache, why is this thing? If it's Apache that's running, would also open a connection to a database and does something on your behalf. So it means that from one, you can pass information to another, and so on. So from direct communication, you could have someone receive a message and do an indirect communication on your behalf. Or from an indirect communication, someone could pass a message direct on your behalf. Right. So people are asking a lot of good application questions. So I'm hoping that by your time, people think of interesting thesis projects. You don't always have to do websites. You can do some things that are a little bit different. I know people like websites and database, right? But you can do a mixture of things, right? So here's another one, right? So this is during the days of Raspberry Pi, when Raspberry Pi came. But it's something that you can even apply to not Raspberry Pi. That is something to say, okay, if you are taking a certain course, right, and you install your CentOS, you can be able to click a button and it will run an installation that will install all the things that you need for, maybe for OS class, all the things you need for DBMS. So that means there can be a web end to it. But I think the last person who worked on it, when you click, it gives you a script that will run. But the next step would be to have an application that's native, almost like a desktop app. That when you click, you can pick. And that means when it downloads the script, it won't just leave the file. It will also run it on your behalf. So maybe look at your version and run it. Your Windows updates and Linux updates work like that. In that there's a program that's on your machine. And that's why when you were doing the YAM, you remember people type YAM and it would say the network is not on. It will try and connect, download, and install on your behalf. And when it's downloading, you'll find all the dependencies. So YAM has a lot of, I think a lot of these Linux and Windows installers these days and updaters are able to communicate your version of your machine, what software you have, and what it needs to install before it completes. Right. So that's all applying these in action. So some part is indirect and some part is direct. All right. So moving on to a new term. I'm sure people have seen this before, like blocking and unblocking, or asynchronous call. You may have heard of them maybe in JavaScript or something. Hopefully, you have heard about synchronous, asynchronous. Right. So in operating systems as well, we cover some of the different types. But I'm just showing you all the different options because you realize operating system is not just about learning how Linux works, but seeing things that are happening in computer systems and maybe applying them to something you're also going to build. Or if you see any other thing that's happening in computer science, you may be able to relate it to this. So what it's saying is there are just two different combinations. Either you're sending or receiving, or you are blocking or non-blocking. Sending and receiving, everyone knows what that is. But it's just a blocking, non-blocking people may not have heard before. So blocking just means that when the operation occurs, right, you are going to wait until a response comes in before you proceed. That means you are blocking for the request to happen. Right. Non-blocking means that you can make the request, but your code will not wait at that line. It would just continue. And then when it's handled, usually what happens with the non-blocking is usually you would specify a function, some handler that when the response comes in, that function should be called on your behalf. Right? Because remember your code, maybe it was saying, oh, get me a file from the website. Maybe your whole code could freeze, your whole page could freeze, but you could say, oh, get me a file from the website. I'm going to go off and display the chart. But when you finish bringing the file, run this code on my behalf. A lot of the Google APIs work that way, like the things that do maps. If you look at it, they will say include the library from Google. It would say when the library is finally loaded, call these functions that will display the graph. That means that if you're opening a website, you open it, not everything displays immediately. But as the different things come in, the charts will start to display, the graphics will display, the animation displays. Right? Or even if you're using YouTube, the moment you visit, it's not that the moment you go, it starts playing. It will say, okay, when the video finishes downloading, play. So that means after the event, everything else in the page is happening, but after the event happens, there's going to be an event handler that will run on your behalf. Right? So that's for the non-blocking. That means you don't wait, you just keep running your code, and when the event happens, some function of yours will be called. There are 4 combinations. Blocking send means that when you are sending, you're going to wait until what? The message is received before you continue. So that means in your code, if they send, it will stop there. If it's a blocking send, you won't execute the next line. For the non-blocking send, that means it sends and then what? Moves on to the next line. Right? Now, blocking receive is similar. Maybe, and sometimes this will happen, you have a program that is waiting to do something. Maybe you want to receive a text message. A lot of the text messaging things work like that. So long as a message does not come, it's just going to what? Wait until a message hits. If the message hits, then you can continue. Maybe when he gets a message, you should insert. But you shouldn't just say, oh, the message has not come, but I'm going to insert to the database. That is kind of a smart way to have a message receiver. Right? Or even if you have something that's checking your mail, you don't want something that just goes, oh, I'm just doing a loop. I'm inserting into your database. So you just insert millions of records. But you'd say, for blocking receive, you'd say, oh, if the message hasn't come, wait. When the message comes, then what? You will insert the data. So blocking send and blocking receive have their benefits. Right? So non-blocking receive, maybe you test and see, did the message come? If not, you go off and do something else. But when the message comes, you'll be prompted so that your process can come back and work on the message. So they all have their benefits. But these are the different ways in which people can send and receive messages. So hopefully after this, anytime you are reading something, whether in JavaScript or C# or, well, C++, you're going to always ask yourself, is this thing blocking or non-blocking? Blocking means that what? It will wait until the task is complete. Non-blocking means that what? It will just continue. You make the call and continue. It won't pause. So is everyone cool with blocking, non-blocking? So aside from JavaScript, are there other places where you can see blocking, non-blocking calls? Communication. Many. There are so many of them. Okay, so telephone is a good one. In that when you make a call, it's not just going to cut and say, well, the call has been made, I'm going off. It's going to wait until the connection is made, you communicate before it stops. But there are some things which don't care, like maybe text messaging. If you send a text message, whether or not the person received it, your program will close and it will stop. Let's say, send message, there you go. And maybe 2 days later, I'll tell you message was not sent. Right? So, text messaging is like that. It's not going to block to wait to send a message. It says, well, waiting. Send it. When the information comes, it replies. Right? So those are two. But there are many others that exist. So anytime you're doing anything in computers, if you see something that's happening, just ask yourself, is this blocking or non-blocking? Blocking means that it's waiting for the response to come in before it proceeds. Non-blocking means it does it and moves on to something else. Okay, so any questions before I move on to the next concept? Don't worry, it's the last one. Almost out of. Alright, so the last thing is buffering. Right. I'm sure you've heard of buffer before. Right. So for messaging, what a buffer means is where does the message get held while it's being received or being sent. Right. And again, there are always two different extremes, right? You can have a bounded buffer. Now, there's something going on with my keyboard. Oh, my mouse is in my pocket. Alright. So that mystery has been solved. Okay, so buffering. There can be what? Bounded buffer or unbounded buffer. So bounded just means that there's a fixed space for receiving messages. Right. So a common example is if you have a SIM card and you are receiving text messages on the SIM card. I think some people do that. You realize when it gets to a point, you say the SIM card is full, can't receive messages. It means that the SIM card has what? Some limited space that it uses for receiving messages. Right. Now, an unbounded buffer just means that the amount of space is not limited, but this time it will allow it to use as much space as the computer system can provide. So it means if it starts, so maybe start with your SIM card, when it gets full, you move on to your memory, and you keep saving until all of your whole computer is full. And then anytime you do something, say your system is out of memory. That can happen. So those are just the two extremes. Bounded meaning that there's some fixed space that is for the message receiving. And if you go beyond it, so for some of the phones, they'll tell you, your mailbox is full, delete some of these. Or you can put a rule on it. Anything older than 2 weeks, delete. Or anything that is 3 days old, delete. You can have all these rules about the buffer size, right? Or even if you have a mail client on your phone, some of them will ask you, how much mail should I keep? And you'd say, maybe 1 month. And that means that there'll be a size there, and it's going to try and manage it within the 1 month boundary. Means that anytime that it gets to 1 month and beyond, it's just going to delete the older messages. Right? So the bounded buffer approach, sometimes it's used with time, sometimes it's used with actual physical size. But it's something that most systems can have to make things more efficient. It doesn't mean that if you have a bounded buffer, you don't have to handle messages. It just means that sometimes there has to be some protocol that would make sure that the messages that are coming are picked off before it becomes full. Else messages will be dropped. So networking works like that. If all of us are accessing some website, all that will happen is for some people, it will display a blank page because maybe the server can't respond in time. So it will start showing blank page. Or if there's a router in the middle, all of us are going through trying to do a lot of things. it will just start to drop some of the requests. So there are some where it's fixed, and if you go beyond, it will just drop. Right. Now, if it's unbounded is just, as I said, theoretical. It doesn't mean that if someone tells you, you have an unbounded buffer, and you say, oh my God, I'm going to put all my movies into that buffer today. Right. It just means that what unbounded, as the computer is running, it will keep allocating more and more space on your behalf. But if it gets full, it will still become almost like a bounded buffer. So unbounded just means there won't be a fixed size, but even if you hear there is no fixed size, as much as possible, there's a sender, there's a receiver. So the receiver should make sure that he picks up the messages before the whole computer gets flooded. So that's the two as far as buffering, bounded and unbounded buffer. Alright, so unbounded buffer, it's almost like saying, so let's use the messaging one on your phone. Right? So your phone could decide that anytime it gets a text message, it will store on your phone. Right? And it doesn't matter how many messages come, it will just keep storing on the phone. And that means it hasn't put a limit on you. There's no bound. But the computer, that's your phone, does have fixed memory. So if the memory gets full, then it will no more function. Right? But a bounded buffer means that your phone or your messaging application, some of them will tell you, we are going to store only maybe 1,000 messages. It won't wait until the whole phone is used. It'll just say there's a fixed size for messages. I'm going to keep 1,000. If you hit 1,000, that is the limit. Please delete messages before what? I can store more messages. That is the bounded buffer approach. Right. So bounded just means that there is a fixed limit that it makes you aware of. Unbounded just means no matter the messages that comes in, it will just allocate as much space as possible to handle it. But it's not going to give you a fixed number. That means if your phone is there, if you put in more memory cards, it will just store more and more. Right. So that's just the difference between bounded and unbounded. Right. So when you think bounded is nice and unbounded, when do you think we should use these? Have you thought of them? Why is it good to have bounded? And why is it good to have unbounded?
Actually, you have bounded to text. Right, so that Leo, for example, doesn't fold your phone, and because your phone is like more space.
Okay. So that's a good reason. Right? So for most phones, they will actually restrict how much messaging you can have, even for your mail app. If you have something like webmail, not webmail, maybe Gmail, the Gmail app on your phone, they'll just make sure that it won't just be, your whole phone is going to be flooded with messages. What they will normally do is sometimes they'll give you a fixed size, or they'll give you a date cutoff. They'll tell you after 2 weeks, all mail after 2 weeks will not be on the phone. That is just to make sure that one application doesn't eat up the entire device. What about unbounded? Would we ever need to use an unbounded buffer?
I think something like WhatsApp.
Is WhatsApp unbounded? Okay, I've not pushed WhatsApp to its limits. Right? But there are some apps, okay, maybe WhatsApp may be like that. Maybe just, it does do that. It doesn't, okay, I've seen this happen to some people, so maybe it does do that. As long as there are messages coming, you'll try and store them. It doesn't just delete your messages, right? No. So for the WhatsApp app, it may just be he can store as much as he wants. Right? Now, there are some cases, so I'll just give another example of unbounded. There are some cases where you have some application on your phone or computer that you really want to run, and you are using it for most of your work. Maybe you are, let's say, you are hosting a certain program, and you don't care, you just want as many messages to come in, right? Or maybe you have a computer web server that is receiving messages. But the purpose of this whole computer is what? Receiving messages. So you don't care how many messages come through. Just say, any message that comes, receive it. For as much memory as I have, as much hard disk space. So there are some cases where you don't want to lose messages. So you'd what? You'd want to receive every single message that is coming through. In that case, you don't put a limit on your buffer. You can just allocate as much as possible. But remember the OS, if it still runs out of space, like your phone, for those who have WhatsApp downloading images, I think that's why I saw that thing happen, where it downloaded so many images, not to say WhatsApp is bad, but just an example, any communication device. It downloads a lot of images, and it'll get to a point, you say, you don't have enough memory, right? And you can't even install. I think that's when people start to realize their phone is full. They can't do an update. Then they have to go and delete some of their pictures or clear some of the conversations, right, before they proceed. there are some cases where even if the conversations, I don't know if you've seen this in some of the chat apps, when people send a lot of messages and you don't check for a long time, it's like 1,000 or 2,000, you try and open the phone, sometimes it just freezes, right? Because now there are so many messages. But it would be interesting if you could, I don't know why they don't have that feature, to say when it reaches a certain limit, just dump it. But I guess they don't want to say, oh, someone sent you a message and you didn't receive it, so you got broken-hearted or something. So for some reason, they keep every message there, and they will leave you to decide when to clear the conversations. I think WhatsApp does that. You wait until you decide, I want to clear the conversations. But something like the mail app for Google, that one won't clear. It will just say, the message is on the server somewhere, right? So it will just say, for 2 weeks, I can download the messages. If it's very old, you will remove it. Right? But WhatsApp is interesting because it is not keeping the messages on some web server. So if you were to clear it, you may never get the message again. Right. So I think it's a design choice in making sure, so long as the message hits your phone, just keep it on the phone. Like unbound it, just keep it on the phone. Because if WhatsApp destroys the message, you will not be able to get it back. It's not on some web server somewhere.
Where you send somebody a picture, you see the picture from your gallery. But if you have like a file explorer on your phone and you browse to the sent, the images, the sent pictures, you still find the pictures you sent to the person.
I think it depends on how you delete. Yeah, you have to check. Because usually when you are deleting from WhatsApp app, I think it's supposed to go and delete it in the folder. But there are some people who, they are browsing it in the gallery and then they delete. But some of the pictures, there could be even 2 or 3 versions. There's a high res, low res. So you could even delete one and there's another one. So where you think you're deleting your pictures. But someone who has enough time will go and find the pictures that were deleted and say, oh, you still took these pictures and we have the low res versions. So I think when you're deleting, try and delete from in the app, right? Completely. Okay. Alright, so that's for all those people who are trying to delete those pictures. Oh, it's a good point. Yeah, it happens. I mean, imagine if someone sends you a picture you don't want to share and then, it's still on the phone. Alright. So that is the end of the different types of communication. Well, so now it is time for questions with the programming assignment. So if people have questions about the fork and exec, I can take those. So, question? Your CentOS is not working. Okay, so. Hey, where's my mouse?